Hey everyone, and welcome to today's Explainer. We are jumping right into Unit 15, which is all about carbon and its compounds. But, I really don't want you to just think of carbon as some random box on the periodic table. Instead, imagine it as the invisible master builder of our entire world. Seriously, from the cells in your own body to the plastic containers sitting in your kitchen, carbon is basically the foundational brick holding our reality together. It's an absolute miracle element. So today, we're going to break down exactly what makes it so special and see how its greatest superpower has also turned into one of the biggest challenges our planet is facing right now.
So why does carbon form over 5 million compounds? Honestly, it's the perfect question to kick things off. Just think about that for a second. This one single element forms more compounds than all of the other elements combined. It's absolutely staggering. Most elements, they might form, a handful of partnerships. But carbon is the ultimate team player. It bonds, it bends, it chains, it links, all to create millions of unique substances. But how exactly does it pull off this monumental feat?
Well, here's our roadmap to find out. First up, the characteristics of carbon. Then we'll look at carbon bonds, followed by isomerism and allotropy. After that, we'll jump into plastics and their long chains, tackle the issue of plastic pollution, and finally, wrap up with our role in all of this.
Section 1. Characteristics of carbon.
5 million. Now, while carbon is actually found in relatively small amounts in nature compared to other stuff, the sheer number of its compounds is just unmatched. And what's even more mind-blowing, that number isn't static. New carbon compounds are literally being discovered or synthesized by chemists every single day. And this massive variety is all possible because of one very specific characteristic.
Now, talking about atoms and molecules can sometimes feel a bit abstract, right? But think of it like this. Just as individual beautiful jasmine flowers are tied together by a single thread to form an intricate garland, individual atoms link together to form molecules. That thread holding the atoms together is what we call a chemical bond. And carbon? Well, it happens to be an absolute master at making these threads.
Section 2. Carbon bonds.
Carbon has this unparalleled ability to link up with other carbon atoms endlessly. It forms these long, incredibly strong chains with hydrogen atoms branching off. We call this property catenation. It means carbon doesn't just stop at simple pairs. It builds long chains, branched networks, and even complex rings. It's basically like a microscopic Lego set with an infinite number of pieces.
Now, what's really interesting here is that carbon actually has 3 different ways of, holding hands with its neighbors. Alkanes feature a single bond, alkenes, they share a double bond, and alkynes share a tightly packed triple bond. And here's the crazy part, simply by changing whether the atoms share 1, 2, or 3 links, the entire chemical identity of the compound completely changes. These different bonds act as functional groups that dictate entirely new properties for the final substance.
Section 3. Isomerism and allotropy.
Okay, if you were to count the atoms in these 2 structures right here, you'd find they had the exact same number of carbon, hydrogen, and oxygen atoms. Literally identical ingredients, but a completely different arrangement. This is called isomerism. It's exactly like taking the same pile of bricks and building 2 completely different houses. Because the arrangement is different, the physical and chemical properties of these 2 compounds are totally different, even though the building blocks are exactly the same.
And then we have allotropy. This is when you have different physical forms of the exact same element. So they have the same chemical properties, but completely different physical structures based on how they were created. To break that down simply, depending on the origin and the environmental pressure a carbon atom is subjected to, it can completely change its physical form. Think about this. Both the soft graphite in your pencil and the hardest diamond in a jewelry store are made of the exact same thing, 100% carbon. The environment dictates the form. Wild, right?
Section 4. Plastics, long chains. Let's bring all that invisible chemistry right down into practical, everyday reality. Those incredibly complex, long carbon chains we just talked about, those are plastics. Take a look at an everyday milk packet. This isn't just basic packaging. This is a long-chain carbon compound brought to life. Carbon's ability to chain endlessly is exactly what gives this plastic its flexible, durable, and lightweight properties. The hard plastic containers we use to store food are another perfect practical example. We rely so heavily on these synthesized materials because those amazing chemical bonds make them incredibly tough and resistant to breaking down. But, as we're about to see, this miracle element presents a massive double-edged sword for modern humanity.
Section 5. Plastic pollution.
See, the very durability that makes carbon chains so amazing also means that when these plastics get thrown away, they don't just disappear. They stick around in our environment for hundreds of years. The source material points out that while these compounds are essential for modern life, some plastics, especially when they degrade or get burned, release toxic chemicals. This creates severe pollution that fundamentally harms both human health and our delicate ecosystems. Basically, the chemical strength of the carbon bond turns into a massive environmental hazard once it becomes waste.
Section 6. Our role. But here's the thing. We are absolutely empowered to make a difference through our daily actions. First, we need to question utility, just asking ourselves if we truly need a plastic item before we take it. Second, actively avoid single-use plastics. They are by far the biggest contributors to the pollution we just talked about. Third, utilize eco-friendly alternatives whenever possible. And finally, apply scientific awareness. Understanding the chemistry, knowing that a simple plastic bag is actually a near-permanent carbon chain, helps us make informed, responsible choices. Your daily actions directly combat this plastic crisis.
So, I want to leave you with one final thought today. The next time you reach for a plastic item, just ask yourself, is it a single-use plastic? And is a few minutes of convenience really worth the permanent damage it leaves behind? Understanding the incredible science of carbon, its 5 million compounds, its indestructible bonds, shows us just how powerful it is. Now it's up to us to manage that power responsibly. Thank you so much for joining me on this explainer, and I will catch you on the next one.